Hey, this is Miss Henderson again. These are your videos for section 1.3.
If you take a look at two rays that have the common endpoint, it turns out they form an angle. Angles are just beautiful, and they appear so often in geometry, it's nice to celebrate them. So I just want us to think about angles and see how we can actually express them and name them. So here are a bunch of rays that you notice all have a common endpoint, D. And they shoot off, and in between them we see various angles. I want us to name 3 angles from this picture. Well, it's sort of easy to do because I can see 3 angles. For example, one angle will be this angle right here. Now, how am I going to write that? Well, the notation that we use is we write a little angle symbol, and then I'm going to write these letters. And the order of the letters always has to be that the center letter is going to be the common endpoint that the two rays share. So in this case, I could write it as A, D, B. And that represents this angle right there. Can I see another different angle? Well, sure. I could see an angle that looks like this. Here. How would I write that one? Well, I'd write that one as the angle symbol, telling me this is an angle. A, D, C. Notice the D has to be the center letter. And can we think of a third angle here? That was this angle right here, this real big one. But is there another angle that we haven't seen yet? Well, there is. There's this little one right here. How can I write that if I want to talk about it? I'd say angle. Now, would I say angle BCD? No. Because remember, the center letter has to be that common endpoint. So I'd say BDC. I could, however, say CDB. That's okay. Either way, as long as the D is in the center. And that describes this angle right here. So actually, naming angles is not a big deal. We use the little naming symbol like this, angle. And then remember that that center letter represents that common endpoint. Angles. And you might have seen them, and I'm sure you're going to use them a lot at some point. Let's just take a look at my protractor, which is so fancy because you can actually read it, which is sort of neat. And let's see if we can actually measure some angles and use the protractor to measure angles. So here you can see various angles appearing. And the first one I want us to consider is to find the measure of angle BOD. The letter O is right here, and traditionally that center angle in this context is usually used with an O. So BOD. I'm looking at that angle right there, and I want to find the measure of it, and we measure that in degrees. How do I denote that? Here's how I denote it. I take the angle symbol, and I write BOD, and I'm going to measure it, and so I put an M in front, and that tells me that's the measure of this angle. So how many degrees is it? Well, the degrees are marked off here, and you can see this is 10, 20, 30, 40, 50, 60, and this D is halfway between 60 degrees and 70 degrees, so it's 65 degrees. And so I write this as 65 degrees. And you'll notice that since that measure is actually less than 90 degrees, this angle is an example of an acute angle. It's an acute angle. Let's now find the angle, the measure of angle. So the measure of angle, you see I write that, measure of angle, and this one is going to be COD. Now let's take a look at where that is. COD. Okay, now that angle right there has some measure, and I want to see if I can figure out what it is. So how am I going to do that? Well, what I'm going to do is I'm going to start here where all the angles begin to be measured, and I'm going to sweep out and find this entire measure of this entire angle. And then what I'll do is I'll subtract off this little piece right here. Notice that this entire angle is equal to this measure plus that measure. So here's what we say. We say that, and I'm going to write this over here. The measure of angle COD equals COB equals the measure of angle COD plus the measure of angle DOB. This entire angle is equal to that angle plus that angle. All right, now we know a lot of stuff. And so let's see if we can sort of put together all the stuff we know. What is the measure of angle COB? Well, I can read that off, and I see this is 120 degrees, this is 130 degrees, this is right between 130 and 140 degrees, so it's 135 degrees. So this quantity right here is 135 degrees. 135 degrees. And that's going to equal the sum of the angles, measure of angle COD plus this measure. But that measure is something that luckily we just figured out to be 65. So it's going to be equal to the measure of angle COD plus this angle, which we already figured out to be 65 degrees. So now I actually have an equation, and I want to solve this equation for the measure of this angle. So what do? Well, I'm going to undo the addition of 65 degrees by subtracting 65 degrees from each side. And when I do that, on this side, you see here, I get this part to 0. I just get the measure of angle COD. And that's going to equal, well, what is this length right here? That's 70 degrees. So this angle measure right in here turns out to be 70 degrees. Another example of an acute angle. Remember, an acute angle is any angle that's less than 90 degrees. If the angle is greater than 90 degrees, then we call it obtuse. Neat stuff. Hey, here's a picture of a bunch of angles here, and we're told a lot of things about them. The first thing we know is that the measure of angle PMR, so that's that really, really big angle there, that has measure 65 degrees. So we're told that. So that's a piece of information that we can use, this entire angle, 65 degrees in measure. The measure of angle QMR, let's see where that is, QMR, so that little wedge right there, that turns out to have a measure of 38 degrees. The challenge for us is, what's the measure of angle PMQ? So that little measure right there, what is it? Well, how can we figure it out? It turns out that if we use the angle addition postulate, we're allowed to actually compute this. Because remember, the angle addition postulate says that the measure of this little angle right here plus the measure of that angle right there is going to equal the measure of the entire angle out here. This measure plus that measure equals that measure. Now, if we apply that here, what would we see? We would see that the entire measure is 65 degrees. And what does that equal? It equals the measure of this angle here, which we know is 38 degrees, plus the measure of this mysterious angle at the moment, which I'll just write as the measure of angle PMQ. Well, now this is an equation just in terms of the measure of angle PMQ, and I can solve for it by undoing the addition of 38 degrees by subtracting 38 degrees from both sides. And when I do that, that doesn't upset the scales and balance. This drops out. I'm just left with the measure of angle PMQ. But on this side, I have 65 degrees minus 38 degrees, which equals 27 degrees. And so that measure right there, that little teeny angle, turns out to be 27 degrees. Here we could see an example of the angle addition postulate working for us in order to resolve this fun little question. All right, let's take a look at this question, which involves angle bisectors, and these are always great fun. So remember that an angle bisector is going to be some ray that has the property that it cuts this angle into two angles, each of which have the same measure. So check it out. I'm told that the ray ZY, which is this ray right here, bisects the angle XZW, XZW. So that means that the measure of this angle right here is going to be the same as the measure of that angle right there. That's what it means to be an angle bisector. Okay, and then we're given all this algebraic information that somehow I want to make good use of. So let's think about exactly what is being said in the rest of these statements. The first is that the measure of angle XZY, so that measure of that angle turns out to be 7x plus 1 degrees. Now notice we don't know what x is. That's an unknown right now, but let's not get scared by it. We just understand that that represents that angle. We're also told that the measure of angle YZW, so that angle right there, has measure 5x plus 11 degrees. Again, there's that same x, but let's not worry. The question is, what is the measure of angle XZW? Well, I need a relationship that's going to bring the x's together in one equation. What do I know? I know that the ray ZY is an angle bisector. That means that the measure of this angle equals the measure of that angle. Or in particular, this quantity equals that quantity. And so we're led to an algebraic equation, 7x plus 1 equals 5x plus 11. That's now a connection that's going to allow me to use algebra to actually resolve this and find x. So let's try to do that. The first thing I want to do is try to get all the x together onto one side, so I have x equals. So I'm going to subtract 5x from the right, which forces me to subtract 5x from the left to keep everything perfectly balanced. And when I do that, here I have 7x's minus 5x's, so I just have 2x's left over. I still have that plus 1. I haven't done anything with that. And that will equal 5x minus 5x is 0, but I still have that 11. Now that 1 is sort of pesky, so let me actually subtract 1 from both sides, keeping everything now completely balanced and nice still. But now I see on this side 2x, 1 minus 1 is 0, equals 10. Well, now if I undo the multiplication of x by dividing both sides by 2, then I see that x has to equal 5. Now at this point you might say, oh my gosh, I'm so tired. Whew, we got the answer, x equals 5. But it turns out that didn't answer the actual question that our friend posed. Because the actual question was, find the measure of angle XZW. All we found was the variable little x. That's 5. So how do I find this angle? Well, first I can plug it back into one of these expressions to find out what one of these measures is. So let's actually plug it in and find the measure of angle XZY. I'd plug in 5 for x here, and I'd see that that angle has measure 7 times 5 plus 1, or 36 degrees. And so what do I do now? I know that this ray was the angle bisector. So if this is 36 degrees, then this angle is 36 degrees. Therefore, the entire angle is going to be 36 degrees plus 36 degrees, or 72 degrees. That equals the measure of angle XZW. So, if you know something about an angle bisector, that gives you lots of information which quite often can lead to an algebraic equation which can then resolve in finding exactly what you want, in this case, sweeping out the measure of that big angle. Congratulations, and I'll see you soon.